as I said, just set up law of cosines, gives you a side angle, side information, and then type it in, and what'd you get? 6.8? Wait, what? Yeah, that could be too big, since the rule is the missing side has to be somewhere between the sum and the difference of these. So it has to be between 1 and 7. So yeah, take square root, and you get 6 point what? Sounds good. Well, it depends on what you round to. So it didn't say, so I don't care. Just don't give me 7 as an answer. Don't round to the nearest whole number. That'd be sad. Okay. Now, before we proceed, write this formula down. And because, frankly, for normal problems like I just showed you, where you just give them the points, want the distance, you just do law of cosines. Draw a picture, do law of cosines, that'll get you through the problem. But we're going to do some that are backwards, and I think it's helpful to have it written out like this. Hopefully you realize that this is just law of cosines. It just has the variables replaced for polar coordinates. And instead of having d squared equals something, it has d equals the square root of that something. You know, it's been rearranged a little bit. But it's still just law of cosines, really. Actually, the formula's still here, but here's the next example we're going to do. All right, let's set it up again. So we're trying to find the distance between the points. The radii are both given, so 6 squared plus 2 squared minus 2 times 6 times 2 times cosine of the difference, the formula says. Here's the deal. Just watch for a second. When you subtract the angles, which, by the way, that's 4, 6 already, right? If I subtract in this order, I get a positive. If I reverse the order, you get a negative. When you see something like this, it's really your choice which one you call theta 2 and which one you call theta 1. So the question is, it doesn't matter which one we choose. In other words, if I do cosine of this, will that be different from cosine of this? The answer is no. Why not? Cosine is what kind of function? Even. With even functions. And watch, just to remind you, if I do the cosine sine picture, looks like this. So yes, if I go positive pi over 6 or negative pi over 6, I get the same exact answer. If it was sine, sine is odd because watch the picture for that one again. Looks like this. So if you go positive, you get a positive angle. If you go the first question, you go the same angle backwards, you get a negative. It's not the same exact opposite because sine is an odd function. So I'm saying it doesn't matter which way you do it. So I'll go ahead and use the positive. Okay. And there you go. Type it in. Make sure your calculator's in radian mode first, but type it in. So, like I said, these are straightforward kind of problems. You really are just doing law of cosine, so you don't have to memorize this formula. But we're going to turn it around. I'm going to call this part B. All I've done is take the last example and assume, that we know the distance, and now we're trying to find that radius. So I'm giving it to you. Okay? And this is the kind of problem where I think it's helpful to have the formula, although really you can still just use a lot of cosines. Set it up that way. But here. Set it up. And we're assuming we know that radius, but not this one. So I'll put that there in the formula. And the first radius here, not the second one. And we already know it's pi over 6, so I'm not going to explain that again. There, we get it set up like that, but now we get to solve. And that's the trick. Right, first of all, let's square both sides. And over here it just cancels the radical, right? I'm going to leave that as just 4.38 squared, because frankly it gets ugly, a long decimal, and I don't want to lose anything with the rounding. And then this side we need to clean up. All that happens really is that you lose the radical. Put the r squared here. Type this in, please. The negative 2 times 6 times cosine of pi over 6. I want to get that just to be a decimal. So, at first period when I did this, I just typed it in as a positive, which was fine. So you should get like 10.39. So 10.39R. I want you to store that, okay? So hit stow and call that B. Alpha B. The reason I'm choosing B is because we're ending up with a quadratic equation of the form ax squared plus bx plus c. And so I want to get it stored that way. By the way, what goes here? Good. It's x squared and mid. And so since it's quadratic, we want to zero out this side. So type in the calculator. 36 minus this. And listen, we're going to not write the whole thing here, but we're going to store it. So store that as C. Store alpha C. And I need A. This is 1R squared, so 1. Store that as A. And I know that's foreign because, look at this thing. We have a quadratic equation. We're not going to solve in factoring. So we're going to use quadratic formula, which looks like this. Quadratic formula is opposite to x solutions are opposite to b, plus or minus what? Good. Square root of b squared. Oh, the 2 goes down here. 4ac. All over 2a. Listen to me. As algebra students, you're expected to be able to solve quadratic equations at the drop of a hat. Like you know Pythagorean theorems, a squared plus b squared equals c squared. You should know quadratic formula, always. So if you have to solve by factoring, you solve by factoring. Otherwise, you solve using quadratic formula. I reserve the right to ask you to solve any quadratic at any time. So next time it comes up, know your quadratic formula. Okay? Now, thing is, and by the way, this is A, A is 1, B is this, C is that. We already have typed in calculator, so I'm going to actually type in the formula. You got to type the numerator first, so the opposite of, open parentheses, opposite of B. I'll do the plus. It's really 2 formulas in 1. I'll do the one with the plus there. Square root, b squared. Type this in. The negative 10.39 we got. And listen, if you didn't get the the better answer, just store what you see there. You'll get a slightly different answer from us. So it'd be close enough to see that you're doing it right. And then be careful. Listen, depending on your calculator, you might have a radical bar across this, or you might have to do parentheses like I'm doing. So make sure it's all closed off before you divide. And you need to divide by parentheses 2a because that's a product. You don't need to leave the parentheses off, you'll get a wrong answer. And, by the way, this was R, technically, that we're solving for. The kind of funny thing is, we didn't get 2, or anything close to 2. Let me do the other version. So do second enter. Change that to a minus. And there's the other version of the other part of the formula. Oh, look at that. In the first period, we messed up somehow because we got something a little farther off. It was 2 point something, but not this close. Anyway, of course, like I said, we didn't expect to get 2 exactly because the distance wasn't really 4.38. It was rounded to that. Look, the point is, we're going backwards. It turns out the 2 we were given here wasn't the only radius that would work for that distance. It turns out if the radius was 8.39, okay, that would also turn out to be the same distance. So here, I'm saying there are 2 answers. They're both valid answers to the question. If you had those points with that distance, either one of these radii would work. And you're done.